much of the equipment, when our district was first created, we got from a grant from the Texas Water Development Board. It's called a 75-25 participation. The Texas Water Development Board, they'll supply 75% of the cost, and the district will supply the 25.
But districts may also make grants and loans in certain cases. For instance, the Texas High Plains districts have assisted ag producers in replacing wasteful irrigation equipment.
Financing of these center pivot systems definitely saves the aquifer lots and lots of groundwater by taking away the high pressure impact sprinklers, which evaporate so much water, go to the low energy precise application, and consequently the water saved by implementing these center pivots is definitely good for the aquifer.
A lot of old abandoned wells exist in Gillespie County.
Abandoned water wells are an immediate threat to groundwater quality across Texas. If left unsealed, these wells provide a direct conduit for contaminants to enter our groundwater supplies. To counter this threat, many districts choose to assist producers in sealing these wells, providing expertise and sometimes more.
We provide to the landowners the material to plug the abandoned wells, that being bentonite chips, and we provide that at no cost.
Basically, what a groundwater district does is level the playing field for all the particular users.
To meet this goal, districts set production limits that apply across the board.
And so we calculated a very conservative average, and that seemed to be kind of the level ground that people could live with.
Another tool used by many districts is well spacing. This assures that neighboring properties do not compete for the resource. The key to spacing is called a cone of depression.
A cone of depression, you have a well drilled down, and that well is going to start sucking water from the aquifer. A sand aquifer is not like a glass of water. You have to move the particles of water through this sand and into the well bore. And consequently, when you're pumping a well, if you start pumping it in this position today, tomorrow it's going to be out to this. You've dried that sand out that's in that cone of depression, so you just dry it out. And in our district, we feel that we dry it out to about 300 foot.
So all wells drilled in Mesa Underground Water Conservation District must be at least 300 feet from the nearest property line. This assures that the water being taken out of the ground belongs to the landowner above.
We have had a situation where a person violated the spacing requirement, and we did take that to the necessary conclusions, and that well was sealed, and they're no longer pumping from that well. The rules of the district are implemented in district court. We would bring a litigation against that person who is in violation. In our particular case of the spacing violation, this particular person just was of the impression that he could violate the rule, go over into a corner of his farm and put an irrigation well there, which consequently 3/4 of the water that he was mining from this well was coming from adjoining landowners. And the adjoining landowners, they protested, they contested the well spacing, and consequently we did stop the well from being produced.
But despite the importance of this power, it is one district seldom have to exercise.
The people are going to follow the rules. The rules are going to be fair and equitable to all the people in the district, so consequently what's good for the goose is good for the gander.
"20 years ago, when I was working in an oil field business, if someone would have told me that 20 years from then that water would be more valuable than oil, I would have laughed.
But that's exactly what water has become.
You just have a whole lot of big cities in the state of Texas that are growing at tremendous rates that don't have enough water, and they're going to go somewhere and they're going to get that water.
That situation has led to the advent of water marketing, where cities, businesses, and entrepreneurs pay landowners for access to their groundwater supplies. And in many areas, this new enterprise is being welcomed with open arms.
My management plan has identified in excess of 60,000 acre-feet of water available from the Carrizo Aquifer above the projected needs of our district. So, therefore, it would be impossible to just sit on this treasure trove. We intend to let the landowners market their resource as they wish.
The district may set up rules to regulate this transfer and assure that it is done in a responsible manner, but the details of the contract and the profits belong to the landowner.
Landowners are free to negotiate their own leases with water purveyors. It is their land, their property.
Our district is one of the unique districts in Texas. We have a used oil collection program. In this program, we have a truck that'll go out to everyone who generates waste oil, and we pick that up. So consequently, we serve every person in Dawson County who has a combustible engine.
This program protects the groundwater resource from possible contamination. Each district provides unique services like this to fit the needs of its public. Water testing labs are the most common of these services.
We do water analysis for anybody in the district who wants their water tested. For domestic and households like that, we do bacteria testing. We do E. coli, total coliform. We do all of this. For the irrigated participants, we do pH testing, specific conductivity, chlorides, and boron for the peanut guys. So we provide this service, and consequently we do a lot of work for our people.
The purpose of the district, besides the regulation of groundwater pumpage, is education, to dispel myths and rumors, to make conservation a way of life.
Districts continually work to educate the general public, landowners, and policymakers to the importance of groundwater protection. And perhaps none of this is more important than the work done with the decision makers of tomorrow.
We found and have developed here a water conservation educational program. We were able to do in excess of 40,000 fifth graders last year, and have done about that same number for the last several years.
This is by far the largest of any district educational program and one of the most successful in the nation.
Kids love it, the teachers love it, the sponsors love it, our board loves it, because in the educational program it actually puts a set of water-saving devices in the hands that the child gets to take home and install at home. And tests proved to us that those saved about 1,400 gallons of water a month.
Nobody likes taxes or fees, but they're a necessary part of funding a district adequately to do the job properly.
The enabling legislation will likely allow groundwater conservation districts to either levy ad valorem taxes or collect fees to pay operation costs, maintenance expenses, and bonds. Each district is different in this regard. The state has mandated that no operation and maintenance tax rate will exceed 50 cents per $100 assessed value. However, it is important to note that to date, only 2 districts have yet taxed at a higher rate than 7 cents per $100 assessed value.
Our fees here in the year 2001 are exactly the same as they were in the first year of our operation, which was 1976, and that's $12 per million gallons.
Every pocket of groundwater in this state is unique. This system allows for the public policies governing use of groundwater resources to be equally unique. It allows for fair access by all landowners. It allows for the management of a resource to change and grow as better understanding of that resource evolves. Groundwater conservation districts are Texas' preferred method for local management of local groundwater resources. They are responsible for the conservation, preservation, enhancement, and protection of groundwater resources, as well as the prevention of groundwater waste and land subsidence, all the while mapping a course for our long-term water needs.
Hello, my name is Todd Sink and I'm a Fisheries Extension Specialist with the Texas A&M AgriLife Extension Service. As you can see here, it's springtime in Texas. Most of the trees are beginning to bud out and most pond owners are once again getting back out to visit their ponds. And many of you are seeing an all too uncommon problem. Some people call it moss, some people call it pond scum, but what it is in fact is filamentous algae. Today with my crack team of undergraduate students, we'll be showing you how to identify the various types of algae and how to manage it in your pond setting.
Hi, my name is Jessie Gwynn. There are 3 different types of algae commonly found in farm ponds and small lakes. These are filamentous, planktonic, and macroalgae. Filamentous algae are made of single cells that form long visible chains, threads, and filaments that intertwine to resemble wet cotton or wool. This type of algae grows along the bottom of the pond in shallow areas and then floats to the surface to form mats, commonly referred to as pond scum or pond moss. This type of algae is unsightly and may interfere with swimming, fishing, or other recreational activities.
Hi, my name is Michaela. Another type of algae you can encounter in your pond is planktonic algae. This algae is microscopic and free-floating algae that exists in the top few feet of a pond or lake where the sunlight penetrates. This type of algae is normal and in fact desirable and essential for the pond's food chain, as they provide food for microscopic animals that are eaten by fish fry and other pond inhabitants, which ultimately support a larger fish population. They exhibit seasonal abundance and often blooming in the spring and sometimes summer, coloring the pond different shades of green, blue-green, or brown. The natural degradation of the algae blooms can lead to oxygen depletion and fish kills in the pond.
Hi, my name is Hannah. One of the types of algae that you can encounter in your pond is macroalgae. There are 2 main types of macroalgae found in Texas ponds, Chara and Nutella. Chara, or muskgrass, is a gray-green branched multicellular macroalgae with whorled branches that is often mistaken for an aquatic plant, but can be distinguished by its lack of flowers. It has a grainy or crunchy texture, does not extend above the water surface, and has a musty, almost garlic-like odor. Chara prefers alkaline, hard-water ponds and grows in rows along the muddy bottoms in calm waters. It is an undesirable species because it carpets the bottom, crowds out other species, and grows rapidly, quickly becoming a problem. Nutella is another type of multicellular macroalgae that are branched, do not produce a flower, and do not extend above the water surface. Also known as stoneworts, this algae has no odor, is soft to the touch, and light to dark green in color with forked, bushy branches. Like Chara, it grows in rows attached to the muddy bottoms of calm waters, and is undesirable because it can carpet the bottom of the pond and crowd out other desirable species.
Biological controls for macroalgae and filamentous algae include Mozambique tilapia and triploid grass carp. Mozambique tilapia will consume some filamentous algae and some macroalgae, such as Nutella, but typically provide limited, if any, control. Additionally, as a warm water species, Mozambique tilapia cannot survive in temperatures less than 55 degrees Fahrenheit, so in all but far southern Texas climates, they must be restocked each spring. Triploid grass carp will eat filamentous algae, but because it is not a preferred food item, they will consume other types of submerged vegetation before filamentous algae. Therefore, they are not typically a reliable control for filamentous algae. However, grass carp readily consume macroalgae such as Cara and Nitella. In Texas, only triploid grass carp are legal, and a permit from the Texas Parks and Wildlife Department is required before they can be purchased from a certified dealer. Mozambique tilapia are the only legal tilapia species that may be purchased in Texas for pond stocking.
Another way of controlling your algae is through chemical control, such as copper sulfate. When using copper sulfate, the aqueous form is recommended. Although it may be cheaper, the granular form requires more effort because it must be dissolved in water and then sprayed onto the pond. Copper sulfate only works as long as it is in the water column, so if crystals or pellets are thrown into a pond, they will sink to the bottom where they will not be effective in controlling algae. Copper sulfate is not effective in hard or high alkalinity waters because it binds with the calcium in the water, forms a precipitate, and renders the copper ineffective as an algicide. Copper sulfate is not effective in cold water. Its toxicity to fish also increases with higher water temperatures, and it should not be applied during the summer. Another method of controlling algae is chelated copper. Chelated copper comes in an aqueous form that must be sprayed over the pond. Unlike copper sulfate, chelated copper doesn't precipitate in high alkalinity waters. It is also more effective in waters with lower temperatures. Chelated copper stays in solution and remains active for longer because it releases the copper ion more gradually than the copper sulfate.
When applying your copper compounds to pond algae, you can either use a hand pump style sprayer or a back-to-back style sprayer such as this, or you can use a larger commercial type sprayer that either goes in the bed of a pickup truck or on the back of a four-wheeler. When you're applying copper, it's important to remember that copper is a contact herbicide. So it's only going to be active on the algae that it actually comes in contact with. Therefore, it's important not just to dump it in the pond, you need to spread it over the surface of the algae, which means you need to spray it on. Remember, when you're using copper sulfate, I want to stress again that you need to dissolve crystals in water before you apply it and then spray it on. As you can see in this instance here, we already have a chelated copper complex mixed up with our water. Copper algicides do have a blue color due to the copper in them, and it's very important not to have these compounds come in contact with your skin because it will dye you blue and you will look like a Smurf for a long period of time. Always make sure you use proper safety attire and make sure you wear a good set of gloves.
All copper compounds can be toxic to fish if they are used above the labeled rates. Be sure to test the pond's alkalinity and adjust copper treatments to alkalinity concentrations. Be very cautious when treating a pond with an alkalinity of less than 50 parts per million, as copper can be toxic to fish. Never treat ponds with an alkalinity less than 20 parts per million. Above all, follow all label instructions when applying chemical controls. Aquatic herbicides are not toxic to fish when properly applied according to the label.
A final way to control the algae in your pond is through physical control. Filamentous algae and macroalgae can be physically controlled by using a rake, a seine, a wire screen, or another similar device, or by physically cutting the algae or removing it from the pond. However, physical control methods such as these are generally laborious and short-lived, as the algae will recolonize very quickly afterwards. Many companies make cutters and rakes that can be used to remove the algae from the ponds. Another method of physical control involves using non-toxic dyes and colorants to shade the pond and limit sunlight penetration that promotes the algae growth. Dyes and shading products are made by companies such as Aquashade, Blue Springs, and Crystal Blue. However, this sort of control method may suppress the natural food chain of the pond by reducing the platonic algae that food chains of the ponds are based on. Shading the pond can also be achieved by using physical barriers to sunlight penetration, such as a shade mat.
Prevention is usually easier and more effective than treatment. The most important key to preventing the growth of algae is to reduce the amount of nutrients entering the pond. Creating a 10 to 20 foot buffer around the pond with taller vegetation to filter excess nutrients, reducing the amount of fertilizer used in drainage areas of the pond, and locating septic fields far away from ponds can help keep excess nutrients from entering the ponds. Another option is to aerate the pond. Aerating with a bottom diffuser increases the level of dissolved oxygen at the bottom of the pond, which in turn increases the number of aerobic bacteria. These bacteria feed on organic matter such as decomposing plants and reduce the amount of excess nutrients released into the water. Algal growth may also be prevented by steepening the sides of the pond during construction. A slope with a 3-to-1 decline helps to eliminate shallow areas that can be penetrated by sunlight and can discourage the growth of algae.
Water is one of our planet's most important natural resources. In fact, it's a resource we literally can't live without.
How much do you really know about water? Did you know there's as much water on the Earth now as there was when the Earth was formed? There will never be any more or any less. Did you know that 97% of that water supply is salt water in the oceans and unusable for our daily needs? That another 2% is frozen in ice caps and glaciers? So that leaves just 1% of the planet's entire water supply, our rivers, lakes, and groundwater, to meet everyone's water needs. Here's the catch. Many of those rivers, lakes, and groundwater sources are impaired, endangered by pollutants. That's right, this limited resource we all use day in and day out is in serious jeopardy. From plain old dirt to toxic chemicals, pollutants in our waterways are threatening our health and the health of the environment. So how are these pollutants getting into our waterways and what can we do about it? That's the complicated puzzle we'll explore more today.
Solving the water quality puzzle is an enormous challenge simply because there are so many pieces to consider. The ways we use water, the practices that threaten it, the different pollutants in the water, and the sources of those pollutants, and hydrology, the water cycle, and ways we've interfered with it. Complicating the puzzle even more, these pieces never combine in exactly the same way. Every community's water quality problems are unique and depend entirely on which pieces are in play.
Simply understanding the role each piece plays isn't enough. To solve problems, you have to understand the fit between the pieces, their relationship to one another. The way they're at work within your community create your specific water problems. Ready to dive in?
The first piece of the puzzle is our absolute reliance on water. It's a resource that can't be replaced, which is why it's so imperative we protect it. Let's take a quick look at different ways we use water. We all need drinking water. A human can go weeks without food, but only days without water. And we don't just need water to survive, we need clean water. Drinking water accounts for a tiny percentage of our overall water usage, less than 1%, but it's one of the most important of all the uses. We also need water that works for us, doing the dirty household jobs like laundry and cleaning, for growing gardens and keeping lawns green. Beyond household chores are the heavy-duty jobs in industry. Water is used in many manufacturing processes, as an ingredient in food production, as a coolant for producing steel and power, as the driving force in hydroelectric generation. The list goes on and on. One of water's biggest jobs is helping to feed the world. Water is essential to agriculture. Without it, farmers couldn't grow crops or produce livestock. Beyond its use in the production of goods, water is often used to transport those goods to market. Waterways are integral to national and worldwide shipping. When water's not working, it's playing. One of its most popular uses is for recreation. Whether it's swimming, water skiing, fishing, the water's got to be clean. Polluted recreational waters spell trouble for both humans and wildlife. Which brings us to the final use, habitat for wildlife. Rivers, lakes, and oceans support entire diverse and fragile ecosystems. Ecosystems that can be shattered by even the smallest changes in water's quality.
We depend so heavily on water. Isn't it ironic that many of the ways we use it are actually impairing its quality?
Careless industrial use of water can contaminate the resource with toxic chemicals. Recreational boats and jet skis can dump gas and oil into the very water we want to enjoy. If the ways we use water were the only practices creating pollution problems, the puzzle would be solved. We'd just change the ways we use water. But it's not that simple. A whole range of practices, the individual actions we take and decisions we make, affect water quality.
We all live downstream of someone else, and there's someone else that lives downstream of us that needs to utilize that water. So it's important to be careful at how you use the watershed and the land in that area and what you might be introducing into that water body.
One person's decision to properly dispose of paint keeps that paint out of a stream. One developer's decision to control erosion keeps sediment out of a river. Multiply those individual decisions across an entire community, and you can see the impact proper practices can have. Practices are closely tied to the centerpiece of this whole water quality puzzle, pollutants. Some water pollutants are easy to see, like garbage, but the most serious pollution problems aren't as obvious.
Sediment, nutrients, chemicals, pathogens.
Sediment is simply soil. It's a valuable resource in a farm field or along a stream bank, but it becomes a major problem when it's washed into waterways. At the root of the problem is erosion.
Erosion off of farm fields, construction sites where you don't have proper sediment control structures in place. You can easily have sediment eroded off of those landscape areas. You can have pasture areas that are overgrazed, animal access, cattle access directly to streams. With all of the trampling along a stream corridor, that exposes bare ground, which in turn exposes sediment to erosion. And then along all of our major rivers, if you don't have a lot of vegetation sort of holding the soil in place, stream banks can be a major source of sediment.
Why is soil so damaging when it's in water? It affects everything from the way water looks to what can live in it. Sediment can block sunlight, influencing what types of vegetation and species can thrive in that water. Sediment fills in waterways, affecting transportation and recreation. And sediment can be a carrier for other pollutants, like toxic chemicals, which attach to the sediment, making it a double threat. Next are nutrients, which pose an entirely different problem. Nitrogen and phosphorus are natural components of manure, human sewage, and decaying organic matter like leaves. They're also present in manufactured fertilizers. Nutrients are applied to farm fields to feed crops and to backyard gardens. They're used to green up golf courses and lawns. They become a problem when precipitation washes nutrients off the land and into waterways. Once they're in water, they do what they do on land, enhance plant growth.
When we have too much nitrogen in the water, your water tends to turn green and you get a lot of algae blooms. When those algae blooms finally die and the algae start to decompose, they take up all the oxygen in the water, and so there's a low amount of oxygen in the water, which causes problems for fish and plants because they need that oxygen.
Nutrients aren't just damaging to watery ecosystems, they also pose a real risk to humans. Nitrates, a byproduct of nitrogen, are especially dangerous.
When we have too much nitrogen in drinking water, for instance, babies, maybe infants under 6 months of age, can develop something called blue baby syndrome. And what that is their blood can't carry enough oxygen. And that can cause some health problems. And in fact, we may have older people or people who are in poor health that can also have that problem.
The risk is so serious that the Environmental Protection Agency, EPA, tightly regulates the levels allowed in drinking water. Chemicals are another class of pollutants. Some chemicals commonly used in manufacturing, mercury, PCBs, lead, are toxic to the environment and humans when they reach certain levels. Because of the health risks these chemicals pose, the EPA carefully regulates industrial waste. Special permits govern...